Hello everyone, welcome back to my channel. Today we are going to learn about Prim's algorithm, one of the most important algorithms used in graph theory and computer science. By the end of this video, you will understand what is Prim's algorithm, why it is used, how it works step by step, and how it just selected a complete example and its advantages and applications. So let's get this started. Imagine you are planning to connect several cities with roads or several computers with network cables. Your goal is to connect every location while spending a least amount of money possible. This is exactly type of problem solved by minimum spanning tree, commonly called MST. And one of the most popular method to find an MST is Prim's algorithm. Let's discuss about minimum spanning tree. Before understanding minimum spanning tree, we first need to understand what is the spanning tree is. A spanning tree is a subset of graph that connects all the vertices. It has three important properties. First, it connects all vertices in the graph, and second one is it does not contain any cycles, which means there are no loops. Third one is if there are n vertices in a graph, then the spanning tree will always have n minus 1 edges. Now, a minimum spanning tree or MST is a special type of spanning tree. It is the spanning tree that has the smallest possible total edge weights. In simple words, it connects all the points in the graph using the minimum total cost. To make it even easier, we can say the minimum spanning tree contains all the nodes in the most efficient way, with the least cost and without forming any cycles. Let's talk about purpose of Prim's algorithm. The main purpose of Prim's algorithm is used to find the most efficient way to connect all points in a weighted graph. It helps us in several real-world applications. It is used to minimize network cost, and it is used in designing communication systems, and it is used to building uh, road network efficiently, and it is also used to connecting electronic system in the optimized way. The final result of Prim's algorithm gives us an optimal solution for connecting all points in a network. The result ensures three important things. All vertices are connected, no cycles are formed, and the total edge weight is minimum. So overall, the Prim's algorithm helps us to design efficient and low-cost networks. Now I'm going to explain why Prim's algorithm is called a greedy algorithm. The Prim's algorithm belongs to a category called greedy algorithms. A greedy algorithm is an algorithm that always makes the best choice available at the current moment. In Prim's algorithm, we repeatedly select the smallest weight edge that can safely expand the tree. This means every step we choose the cheapest possible connection. So, in summary, the Prim's algorithm is called a greedy algorithm because it always selects the minimum weight edge at each step to build an optimal solution. Now, I'm going to explain how Prim's algorithm works. Let's look at the procedure step by step. Step 1, we choose any vertex as the starting point. Then we add it to the tree. Step 2, we look at all edges that are connected to the vertices already included in the tree. And in step 3, we select the edge with the minimum weight that connect to the vertex outside the tree. In step 4, we add that edge and also add the new vertex to the tree. In step 5, we repeat this process until all vertices become a part of the tree. The important rule in Prim's algorithm is we always choose the smallest edge that connects to the current tree to the new vertex. This ensures that no cycles are created. So, in summary, Prim's algorithm builds the minimum spanning tree step by step by always selecting the smallest possible edge. Let's learn this further with an example. Now I'm going to demonstrate how Prim's algorithm works using visual graph animation. Here we have weighted graph with 4 vertices 0, 1, 2, and 3. Each number represents a node in a graph. The lines between them are edges, and each edge has a weight which represents the cost. The goal of Prim's algorithm is connect all these nodes using the minimum total edge weight without forming any cycles. So let's start. We start by selecting any vertex. In this case, we start with node 0. This node now added to the tree. Now we look at all edges connect to the node 0 and we compare their weights and select the smallest edge that connect to the new node. In this case, the smallest edge is formed from node 0 to node 3. So we add node 3 to the tree. So now the tree contains node 0 and 3. We again look at all possible edges connect to the tree to outside nodes. So we chose the smallest valid edge which contain node 3 to node 2. So node 2 is added to the tree. So now the tree contains node 0, 3 and 2. We represent the same process again and the smallest edge that connect new nodes is from node 0 to node 1. So we add node 1 to the tree. Now all vertices are connected. This means we have successfully performed the minimum spanning tree. The highlighted green edges represent the final MST. So they show the most efficient way to connect all the nodes with the minimum total cost. So in summary, in this animation shows how Prim's algorithm build the minimum spanning tree step by step. So by always selecting the smallest possible edge. Now I'm going to explain the advantages of Prim's algorithm. First, it is very simple to understand. The algorithm follows a straightforward, step-by-step process which make it easier to learn and implement. Second, it's produce a minimum cost solutions. It always guarantees a minimum spanning tree which ensure the lowest total edge weight. So third, it is efficient for dense graph. That means it works very well when the graph contains a large number of edges. The fourth, it is widely used in real-world applications. It is used in many optimization problems such as networks and road systems and electric connections. So, overall, Prim's algorithm is simple, efficient, and very useful in real-world problem solving. Now, I'm going to explain applications of Prim's algorithm. Prim's algorithm is used in network designing. For example, it helps connecting computers using the minimum amount of cable length. And it is used in road construction. It helps to building roads between cities with the minimum possible cost. And it's used in electrical network. It helps connecting power station in an efficient way to reduce cost. And it is used in telecommunication systems, for example, designing telephone and internet networks efficiently. And finally, it is used in water distribution system and it helps to creating a pipelines with a minimum installation cost. So overall, Prim's algorithm is widely used in many real-world systems where we need to connect points with a minimum cost. Now talk about time complexity of Prim's algorithm. The efficiency of Prim's algorithm depend on how it is implemented. When we use priority queue implementation, the time complexity is O of E log V. Here, E represent the number of edges in the graph and V represent the number of vertices in the graph. This means the algorithm become efficient even for large graphs. So it can handle graphs with many nodes and edges efficiently. So in summary, Prim's algorithm with priority queue is efficient and suitable for large-scale graphs. This algorithm is an efficient method used to find the minimum spanning tree of a weighted graph. It helps connect all vertices with the minimum total cost without forming cycles. Because of its simplicity and efficiency, it is widely used in real-world applications such as network designing, road construction, and communication systems. Overall, Prim's algorithm is an important technique for solving optimization problems in a graph.